Alright, so in the last video I kind of showed a mock-up of running a closed loop servo on the printer port. So there's some questions on, and it's try to actually explain it a little better. So the printer port, which is running through this terminal block, is running pulse density modulation to the servo amp, which is then running this servo, and then the servo has an encoder which is going back to the printer port, or the terminal block. So if you look at this is the z-axis of the lathe. So if you look at the z-axis on Linux CNC, you can see when I turn the timing pulley, this is the feedback to Linux CNC. And when we enable the drive, this is the, if you see the mouse, I'm gonna turn this on. Now this is locked, and when I try to turn it, you can see stuff happens. So the bottom trace is the PID error, which is a tenth of a thousandth per division. So you can see me trying to turn it moves it less than a tenth. And the middle signal is the pulse density modulation going to the drive. You can see as I turn it harder, the duty cycle gets larger. And the top trace is just the direction pin. So it's either on or off. So off, on, off. And so how this works is the encoder is fed back to Linux CNC through a PID loop. The PID loop is tuned so that when you try to turn the timing gear, it tries to push back. Or just it tries to keep position. And you can jog it too, like if I jog this, you can see it's spinning, and then my air, like you can see the air almost gets to 2/10 when I'm just, you know, jogging it spastically, which is not a problem whatsoever. So if you look at when I'm trying to turn this, you can look at the Z position, and I'm moving maybe what, a tenth, maybe 2/10. So the other thing is because this is closed loop, I have following error, which you see the bottom trace is PID error, which is technically following error within Linux CNC. And right now I have it set to 1,000. So if I force this, because I'm only running it's a laptop power supply that is like 4.5 amps, I can actually make this Dell power supply overcurrent. So if you see this, if I turn it, and boom, it's off. You can see Linux CNC. Oh, I'm gonna move this up. I have a joint 1 following error because joint 1 is the z-axis, because I moved it, when I turned it, the power supply failed, and then I turned it far enough that Linux CNC saw the difference between where it thought it should be and where it was, so I got a following error. But now, now I turn it, you can see it keeps track of position, which is awesome. That is like, steppers work fine, but a servo that has feedback to the control, so the control can keep track of position, is so nice. On our big machines at the shop, I can like turn the machine, the actual Linux CNC off, like turn off the drives and everything, Linux CNC still keeps position. So I can come back a little bit later, turn the hydraulic units back on, turn the drives back on, and it knows exactly where it was, and I can take off where I left off. With a stepper, you stall it, you have to rehome it, or you have to figure out your home again. That's what's really awesome about this type of setup. Granted, a Mesa card or Mesa hardware or whatever other hardware out there, I use Mesa, it works really well. Whatever you're using that does this closed loop within Linux CNC, it's awesome. It works very well. So what else was I going to show you? I think that kind of explains it. If you have any questions, post them in the comments, because hold on, let me reset this. I'll reset this power supply. You actually have to unplug it for a while before it will come back up again. See if this worked. Yep. So I don't know if you can see this right here. Can you see the change in color when I enable it? If I go over here and I enable the drive, when I turn Linux CNC on, it goes from red to green. So that's all part of this. It's really a relatively simple control loop, and it makes CNC so much nicer when you have the actual position back to Linux CNC. It's honestly not too many controls can do this, and Linux CNC is free and open source. I'm actually going to try this with one of those cheap Raspberry Pi drives that you can get that take PWM in. It should work similarly. I mean, these drives, you can get them pretty cheap off eBay, but you can get those other drives for less than $10, and they should work similarly. These drives are nice because they have current limiting, and they just work. But finding them inexpensively on eBay is sometimes a challenge. So I hope this kind of helps explain how this is how this is working. This is not step and direction. This is actual process control, PID, within the computer, closing the loop. If I can actually show you the PID settings within Linux CNC for joint 1, which is the Z axis. So here's the input scale. The gearing of this lathe makes it so that it's a pretty high counts per inch. This is 50,800 counts per inch, and the P is 700, the I is 100,000, D is 2.5. Then there's a little bit of feed forward 1, and a little bit of deadband. And it's funny, once you get this setup tuned relatively good, you can just throw I at it, and it just makes it so that it really pushes back against you, which is really cool. As I try to push this, it fights me, and the error is less than 1/10 of a thousandth, plus or minus. I think that's pretty freaking cool. And this is all through the printer port. Again, Mesa hardware, so much nicer. It moves this pulse width modulation generation and encoder counting, and what else does it do? High speed IO. It moves that out into hardware. Linux CNC still, see my hand, I'm talking with my hand. Linux CNC still closes the loop, but the high-speed stuff is outside on the hardware, on the Mesa hardware. Encoder counting, pulse width modulation. Step generation is the other big thing. So I hope this kind of shows what I'm so excited about. Kind of, maybe a little bit. If I zero this axis, you can see as I try to force this, it only goes a tenth, plus or minus a tenth, and you can see it on the Halscope also. So Halscope is also part of Linux CNC. It is an awesome tool for tuning. You can see me using it to show the PID error, so I can adjust the actual values here to get the best following error. So I hope this helps. I guess have any questions, please put them in the comments and let me know. Thanks for watching. Talk to you later.